What's up, folks? This is the 2015 Lincoln MKX. Just 2 minutes of your time. I'm going to sit there and talk for a little bit, and we'll jump right onto it. But just to give you the rundown and caught up, this is a flood vehicle that has sustained quite a bit of damage. Not only is the carpet and the interior all damaged and messed up, but the seats, body control modules going to have to be replaced. The windows were all frozen, all of them. And yesterday we wound up diagnosing and replacing the liftgate module. That successfully works. Moving on to replace other things that I find necessary to document. Why not? It may help somebody else. So I'm not going to document every single thing, but I will document things that I find important. Today I did wind up changing the transmission fluid, and I'm glad I did mention the fluid recommendation, because what happened when I pulled the dipstick, the fluid didn't look black. I mean, it did look black, but when I went to drain it today, since we got authorization to go ahead and repair everything, the fluid was a strawberry milk color. So I did 2 flushes right now, and I'm going to do 1 more flush after I drive it. But today we're going to diagnose this blower motor and the blower resistor. The blower resistor, like I said, is actually the problem with this vehicle, but I'll try to give some pointers on just a quick test for the blower motor. The blower resistor resides here in the HVAC box. It's held in by 2 Phillips head screws, right there and one right there. To gain access to this, you can simply just remove the fresh servo motor for the fresh air. And there's, you gotta be careful because the heater core's right here and it's hot. You'll take a Phillips head screwdriver and get off into the side here and screw these out like so. So you got a lot more room once you get that connector out, and then you'll get the other side the same way. So you'll just get the screwdriver in there and work on getting that out. If I can look down in there, I can't see that well. There's a lot of little stuff in the way, but yeah, you'll just there's the screw right there. There you go. And you'll just work on unscrewing it. And for the sake of the video and diagnostic purposes, I'm gonna go ahead and remove it, because I'm 100% confident that this is bad, and we'll go test from there just for clarity. So unscrew. There's 2 ears on the side here. They need to be disconnected and pulled out. This blower resistor has 4 inputs. The main power feed, the power supply, is a low voltage reference, which is the ground, and it's going to be one of these thick wires. One of these wires go to the blower motor itself, and then the other wire is grounded at the frame somewhere on the vehicle. So these 2 can be jumped, and I'm going to show you that. The blower motor has constant power supply, so when I jump these wires, the blower motor should work. All right, the control side, and this is what we're going to verify. We have control from the climate control head here. So when we turn this front control module or climate control head on, one of these wires are going to supply a command, and then the other wire is a feedback wire. So it's a speed verification. So look at it like an ignition confirmation. you have a command from the computer, and then you have one wire taking in that information, going back to the unit to verify the speed of command. So just to verify that our blower motor worked, we're just going to simply jump these 2 wires. So I'm just going to cut this car on. I have my jumper wire, and I'm jumping the 2 fat wires, and we have blower operation. So that's just the indication that our blower motor works and we have good power supply. So like I said, I already tested this. Not really going to go too much further on that. The main thing we need to know is how this signal is operated, and it goes from the climate control head here to this blower resistor, and we're going to test that wire, that command wire. So what we need to do, we need to get our scope. Well, I got a couple options here. I'm going to use a voltmeter first, just in case you don't have an oscilloscope, and which is going to be perfectly fine for this particular case. And then we'll just look at the values on oscilloscope, the feed and the command and the return wire for the signal. So let's hook up find our signal wire, our command wire from the HVAC, and just change the variance of speed. We should see a change in voltage. It's not going to be anything significant, but we need to see that there's some sort of variance in value. All right, currently I'm pierced in the constant ground supply that goes from the blower resistor to the frame, which is going to be the red and black wire, and then I'm hooked up into the control side, which is going to be this red wire also directly over it. Right now, since I have it on full blast, it's making 10.5 volts, and when I change the speed, let's just go down, it drops in value. I'm going to go up full blast, and it changes. So that's as far as the voltmeter is going to get you. Let's hook up the oscilloscope and see what that looks like. But with this test here, the device is going to have to be plugged in because you're not going to be able to extract a proper signal. I got the oscilloscope hooked up. I'm on channel A. I'm going to use a cigarette lighter as my ground. So what we were looking at, this is a linear representation on the oscilloscope from what we were seeing on the test meter. And it's maxed out on full blast right now. So what I'm gonna do, I'm gonna turn it down, and then we'll see the value change. And just like that, it dropped. So that's what we saw. But this is not a frequency. We need to see some sort of sine wave or digital square wave. We don't have that. So we need to plug the unit in there. Because of the intelligence level of this device, it does recognize when there's no backfeed sensed, and it's just not going to operate. So let's just plug in the bad one and monitor this. So what I will do, when I do get this plugged in, we monitor the feed. We need to monitor the feedback also. So we're going to have to plug in into the back of that brown wire. That's going to be the wire that senses the feedback. So pierced in at the blower resistor at those 2 small wires. So the red trace, our channel A, is going to be our command wire, which is on full blast right now. It should be on full blast. It's showing 12 volts. So this is probably a byproduct of just some sort of backfeed. I'm not too certain as to why now it's showing 12 volts when it's on low. But this is why the component needs to be plugged in. But let's see what happens now when we give it full signal. It just shows 12 volts. So there's no operation of the blower motor, nor do we see any sort of sine wave. It's just 12 volts on channel A. So channel A is our primary wire for control. No blower operation. Let's I don't know, let's spin the motor and see what happens. I'm gonna put my hand down there and spin it. Nothing's going on. Let's go to channel B. Let's just spin it. See if nothing's happening. Yeah, the blower motor's just not working. Let's plug the new unit in here, and I'm gonna show you where I got that from. If y'all know, I frequently patronize O'Reilly's. It's a bittersweet relationship. This is the blower resistor. It was over $150. The part number is RU793. It's a standard motor product. This unit comes in a package, and it comes with some screws. I probably took those out when I had looked into it, but it does come with additional screws and stuff too. Just this and 2 screws. So we're gonna pop this in here and just have it sitting freestanding, and then we're gonna look at our values and see if it restores our operation of our blower motor. So right now we got the new unit installed. It's just freestanding right there where the old one was. And just looking at the data, there's on channel B 12 volts. We have battery voltage. So we still don't see any sine wave, but then again, we don't have it on. So let's cut this device on. So we have operation now. And here we go. We actually had some regulation in speed there. Let's go ahead and, it's on full blast. Let's turn it down a little bit. Okay, so on full blast, it's just gonna go straight linear. So when you turn it down to medium high, we start to see waveforms, and they're matching. Let's go even lower. This is halfway, this is mid. So you can see our command on our red trace and our feedback on our green resembling our command signal. So we have operation there. This is the things that you can't see with the oscilloscope. There's our blower operation. I do need to replace that cabin air filter, which will get replaced. So what I'm gonna do, I'm gonna put this back in reverse order, and this is just another thing on the list that is repaired. If you have any questions, I'll definitely answer those in the comment section. But I think this was pretty much cut and dry for what we need to observe. This was just simply just going to be the blower resistor diagnosis. That little quick test verified that the blower motor works, but we need to know if we have appropriate command, which we verified, and we had good grounds going to our unit. So like I said, when we jumped that, it worked. We needed a command state, and we didn't have that. So there we go. So we're in good shape. All right, if anything happened, I'll definitely update. Hit that link, subscribe to the channel, stay informed how the original's gonna work, and I'll see you next one.